How hard is it to build an image processing service? Honestly, not that hard. You grab some cloud APIs like remove.bg or replicate, hook it up according to the docs, pay per request and call it a day. Congrats, you're now a startup running on someone else's rails. But now let's sleep on both cheapskate mode and paranoid mode. At the same time, we don't want user data flying off God knows where, we don't want to pay 20 cents per image, and honestly we want full control and we want it dirt cheap. Cheaper than anyone else can do right now. This is where things get interesting.
Chapter 1. The price of the issue.
How much does it cost to remove a background from an image? If you're a regular user, probably free. You go to some website, upload your photo, download the result, easy peasy. Sure, those crazy sites will force you to download in low resolution or slap an annoying watermark on it, but you'll still get the job done. But now imagine you want to build a service like this by yourself. That's when things get spicy. Remove.bg charges about 20 cents per image through their API. Doesn't sound too bad, right? But let's do the math. 1,000 image a month, that's already $200 bucks. 10,000, $2 grand. And that's just one tool. What if you also want upscaling, object removal in painting and so on? AI service APIs are expensive, like really expensive, especially if you're from a country where the average salary is, let's just say, not exactly Silicon Valley level.
Chapter 2. Mining GPU cards.
And that's when I remembered. I've got a bunch of old mining GPUs sitting in my garage. 9 of them are NVIDIA P106 cards. They are basically GTX 1060s, but without display outputs. Can't hook up a monitor, can't play games, gamers don't want them, miners don't profit from them anymore. You know how much this stuff go for in used market? 20 to 30 bucks a pop where I live. I'm not kidding. $20 for a GPU with 6 gigs of VRAM and CUDA support. On eBay they somehow more expensive, but in my local marketplace 30 bucks is the max you'd pay. I dusted off 9 of these bad boys, that's roughly 250 bucks saved, which is about what 1 month of API costs at modest usage.
Chapter 3. Real costs.
Okay, but electricity costs money too, right? Oh, this is where the Belarus magic kicks in. Electricity here costs about 6 to 9 cents per kilowatt hour. For comparison, in Germany it's from 30 to 40 cents, in California from 25 to 30 cents. A P106 under load pulls about 100 watts. But here is the thing, the GPUs aren't running full blast 24/7. They wait for tasks, process an image in a couple of seconds and go back to waiting. At average load, my rig with 9 cards pulls about from 400 to 500 watts, plus the system, CPU, RAM and all that stuff, so roughly 600 watts on average. Let's do the math. 600 watts times 24 hours times 30 days equal 432 kilowatt hours per month. 432 times 6 cents equal about 26 bucks, so $26 a month for the electricity to run entire backend for 1 month. For comparison, through APIs, that money would get me 130 images processed. My rig can handle thousands. Sounds like cheating, but it's not cheating, it's some kind of arbitrage between cheap electricity and expensive APIs. Of course, there are caveats. GPUs wear out over time, internet costs money, I've got 500 megabits for 11 bucks in my country, front-end server another 20 bucks on DigitalOcean, Cloudflare R2 still within the free tier for now, but that won't last, I think. But even with all those costs, it's peanuts compared to API pricing. And here is the question, what can you even run on a P106 with its 6 gigs of VRAM?
Neural networks and privacy.
So let's be real, removing backgrounds, upscaling resolution, erasing unwanted objects, this used to take dozens of minutes in Photoshop and actual skill. Now neural networks do it in seconds. But there is a catch. Most services work like this. You upload your photo to someone else's server, they process it, you get the result. But what happens to the original? Where does it go? How long is it stored? Who gets to see it? These questions are usually answered in the fine print of user agreements that nobody reads. July 2023, Lens AI, you know, the company behind those viral AI avatars, gets investigated because they were keeping user photos longer than they claimed. And it turned out some of those photos were used to train their models, so your face is potentially a part of dataset right now. Nice to meet you. And this isn't one-off thing. Pretty much any free image processing service monetize your data somehow. Either they sell it directly, use it for training, блять, чё нахуй, or show you ads based on what you upload. Okay, let's build our own.
Chapter 5: How Neural Networks Work.
First question, what do these image neural networks even run on? In image processing, the foundation is convolutional neural networks. Don't freak out, I'll explain it in simple terms, at least I will try. Imagine you have a photo. It's just a grid of numbers. Each pixel has red, green and blue values. Now take a small window, say 3 by 3 pixels, and start sliding it across the image. At each position, you multiply pixel values by some weights and add them up. You get a new number. Sounds pointless? It's not. If you pick the right weights, that little window can detect object edges or even textures or faces. That's what a convolution is. Now imagine hundreds of these windows, working one after another. The first layer finds simple lines and edges, the second layer builds corners and shapes from those lines, the third layer builds object parts from those shapes, and so on until the network starts to understand what the cat and what the background.
Chapter 6: Which models I use.
For background removal, I used a model called BRFNet. It's an architecture that's really precise at detecting object boundaries. You know, when the hair in the photo doesn't turn into a blocky mess, but actually stay looking like hair. It's got this clever system with bidirectional connections. The model looks at the image both top-down and bottom-up, constantly refining the result. For upscaling, I used real ESR gun. That's the thing that takes a blurry 480p photo and makes it look more decent. It runs on generative adversarial networks that when one neural network tries to create an image and another tries to tell it apart from a real one. They compete until the generator learns to fool the detector. And for object removal, simple llama. You can cut out an unwanted person from a photo and the network fills in what should have been there. Magic? Almost. Really, the network had just seen millions of images and roughly knows what the background behind a removed object should look like.
Chapter 7: Hardware.
All these neural networks need GPUs, a lot of GPUs. Either rent in the cloud at $3 an hour per card or hit the used market and buy retired mining cards. So meet the Nvidia P106 video cards, 9 of them. All this hardware sits in the closet, literally, not in a data center, not in a server room, in a closet, in a Belarusian apartment. The CPU is an Intel Pentium, 2 cores, 4 threads. It's like having a cyclist drive a race car. But you know what? For our purposes, that's enough. The CPU just distributes tasks to the GPUs. It's not doing any heavy lifting itself. 20 gigs of RAM, system drive, 128 gigs SSD.
Chapter 8: Architecture.
And this is where the architectural magic begins, or madness, depends on your perspective. The front end, what the user sees, is built with Next.js and lives on server in San Francisco, DigitalOcean, legit cloud stuff. The backend, what actually processes images, is Fast API on Python running in that same closet. So the flow looks like this. A user from Berlin visits the site is served from San Francisco, and when image needs to be processing, the request flies to Belarus, right to the closet. Globalization! Cloudflare sits between the frontend and backend. It's like a proxy shield that protects against stuff like DDoS attacks and cache static content. Plus it hides the real server IP, because if someone finds out the backend is a home internet connection, well, you get it. For task queries, I use Redis. It's a fast in-memory database. When an image processing request comes in, it doesn't run immediately. It goes into a query and dedicated workers, 1 per 1 GPU, pull from that query.
GPU role system.
Here's the trick. I've got 9 GPUs and different tasks have different requirements. Background removal, it's about 5.5 gigs of VRAM. Upscaling can choose through 3 to 4 gigs of VRAM. In painting, around 3. So I built a role system. In the config, the first 2 cards handle background removal only, the next 2 upscaling only, 2 more in painting. The remaining ones are either in reserve or join whichever query is busiest, and I can change roles on the fly. No service restart needed. Update the config, Redis broadcast the notification, workers reload their settings. Beautiful!
File uploading.
About file uploads. This is a whole separate headache. When a user uploads an image, it doesn't go straight to my closed server, because home internet is not a data center's gigabit channel. Instead, I use pre-signed URLs for Cloudflare R2. It's object storage like Amazon S3 but cheaper. Here is the flow. User says, I want upload an image. Frontend asks the backend, give me upload URL. Backend generates a temporary link that's lived for X minutes. That's a secret. User upload the image directly to R2 storage, bypassing my server. Backend get notified the file is uploaded and queries the task. Why all this complexity? Because if 100 people start uploading photos directly to home server at once, that home internet connection dies. Cloudflare handles way worse. Sometimes it also fails, but usually.
Identification.
There is no registration demand. When you visit the site the first time, a fingerprint is generated in your browser. It's a hash of bunch of parameters, screen size, installed fonts, time zone, and so on. The fingerprint is sent to the server and JWT token is created from it. JWT is like encrypted pass. It's stored in HTTP only cookie, meaning the JavaScript on the page can't read it. Also, it's protection against XSS attacks. Whichever request the browser sends both the token and the fingerprint. The server checks that they match. If someone steals your token, they can't use it from another device. The fingerprint will be different.
Chapter 12. Payments.
A third-party payment system that's been around for years means I don't collect any card data on my end. I literally cannot see what card details user enter. I just get a token from the payment provider and notification whether the payment was succeed or failed.
Security and privacy.
As for the other data, I don't store anything except email addresses. And since authentication is done through Google, that user data is safe too, because you don't have to create a password on my website, so no one can steal your password, because this is not exist. When a neural network processes an image, it needs somewhere to store intermediate result. Writing to SSD disk slow, so I use TMPFS, a file system that lives in RAM. Image processed, result sits in RAM, delivered to the user and deleted after that. The SSD isn't touched at all, because I don't want to use its resource. I think the cheap SSD will die very fast if I will use it, so I don't use it at all. It just stores Ubuntu files and some backend files. All writing and reading operations are in the RAM. Fast and secure, and after reboot, there is nothing left.
What can go wrong?
Now for the honest part, because if I only talked about the wins, I'd be lying.
Problem 1. Electricity.
9 GPUs pulls about 600 to 700 watts on the full load, plus CPU, plus drives. If the power goes out in my apartment, the service goes down. I don't have a UPS rated for that kind of power. But the power hasn't gone out once in the past year. I can also buy a UPS if we'll need it.
Problem 2. Cooling.
The closet can get toasty. Right now my cards aren't throttling or overheating, but who knows what the summer will bring.
Problem 3. Scaling.
If tomorrow I get 100 times more users, the system won't handle it. Cloud services can scale, you just buy more servers, you're done. But here, rent another closet? I've got a plan to completely rewrite the backend architecture and move the backend to the server, and using GPU rigs only as workers place it in the different apartments. Madness and bravery, I think.
Problem 4. Vibe coding.
I'm not a programmer. I don't know code at all. This whole project is pure vibe coding using Cursor. Why am I telling you all this? I could have made a landing page with pretty pictures, written our servers are SOC 2 complained, and not bother people with the technical details. But I think honesty matters more than marketing. Yes, that server sits in the closet. Yes, I use second-hand mining video cards. Yes, this isn't an enterprise solution with the fine nines of uptime. But I know exactly what happens to your images. They get processed, you get the result, the original is deleted. Nobody uses your photo for training. I don't have even GPUs for training. Nobody sells them to ad networks. There is physically nowhere to store them. I've got only 200 gigs on the SSD, and I'm not about to waste its lifespan on rewriting files. Instead, files are written to the RAM and deleted immediately after processing. And another thing, it works. It actually works. Background removal from 2 to 3 seconds, upscale 5 to 7 seconds, object removal approval 3 to 4 seconds. For a home server, it's not bad at all. So what's next? Lots of plans. I want to add an image generation, stable diffusion or flux. I want to improve their upscaling. They are way better open source upscalers than real ESR Gen, but they need a lot of RAM, and it even need to combine 2 or 3 GPUs in one worker, because the task splits into separate stages. I want to make an API for developers, so people can integrate the processing into their own services. So I need to think about billing, documentation, and support. And I think that will not a hobby project anymore. That will be a job, I think. I want to move to proper hardware, several GPUs with 24 gigs, but one of those cards costs way more than my entire setup. I don't have such money yet. Anyway, check out my quickimg.com, link in the description, and subscribe to my channel. Please, 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 please.